All right, the second problem, we're looking for up to 3 answers. So I'm going to do plus or minus p over q, which is plus or minus the factors of my constant over the factors of my leading coefficient. So I'm going to write all of these out. Plus or minus 1 over 1, plus or minus 1 over 2, 1 over 1, 1 over 2, plus or minus 2 over 1, plus or minus 2 over 2, plus or minus 4 over 1, plus or minus 4 over 2. So every number on the top has to be put over every number in the denominator. Clean them up. Plus or minus 1, plus or minus 1/2, plus or minus 2. These two are the same, so I'm not going to write it again. Plus or minus 4. And that's going to be it because the last one is the same. So those are my 8 possible solutions. All right, so I'm just going to try some numbers. I'm going to try positive 4, 2, negative 1, negative 8, 4. Synthetically divide. All right, that's not going to work because my number's going to get way too big. All right, so let's try something else. Let's try 2. 2, negative 1, negative 8, 4. 2. Well, that doesn't look like it's going to work either. Oh, that's why, because that should be positive. And there we go, I got one to work. So what I have left is 2x squared plus 3x minus 2. This factors, I'm going to have a plus or minus, multiply to give me 4, subtract to give me 3. So I'm going to use 4 minus 1. Group by 2's. So I'm going to say my solutions, 2, positive 1/2, and negative 2. I see when we have an x to the third, we're looking for one good answer. Once we find one good answer, we're going to synthetically divide it out and then work with what we have left. All right, let's do this. I'll show you. If I would have tried negative 2 from the start, all right, 2x squared minus 5x plus 2 would have worked. And if you would have factored that, you would still get the 3 answers. So when there's 3 good answers, as long as you find one and get it down to an x squared, we should know how to solve x squareds. All right, so if a plus bi is an imaginary root, then a minus bi is also a root. This is rational roots come in conjugate pairs. Don't worry about that. If a plus bi is an imaginary root, then a minus bi is also a root. What this is saying, imaginary answers always come as a plus minus. If I give you 1 plus I, then another one is also 1 minus I. 3 plus, or 3, let's change that. 3 minus I squared to 7. You automatically get 3 plus I squared to 7. Right, same idea. I's always come in pairs. All right, so they'll come and play in the, not this one, but the next one. All right, find the third degree polynomial with the given zeros. We did this on the quiz. If I want this polynomial, I'm going to put the opposite into a factor and FOIL. So I FOIL the first one with the second one. Then I get x squared minus 3x plus 2. Now I need to FOIL with x plus 3, so I'm going to take x squared, multiply it times the back. Negative 3x times the back, and a 2 times the back. So I get x to the third plus 3x squared minus 3x squared minus 9x plus 2x plus 6. X squared times the back, negative 3x times the back, and 2 times the back. Add like terms. X to the third, those cancel, minus 7x plus 6. So that would be my function or my equation. All right, we did this on the quiz, we've done this. When we have a solution, we put the opposite into the factor and FOIL. All right, this one I tell you three.
Attention in the building, please pardon this interruption. Please be sure that all doors come shut and latch. Once you enter the building, please do not prop any doors open. We are in full school mode, even though we do not have children. We want to ensure everyone's safety and well-being. Thank you all so much.
All right, so make sure when you come into the buildings, you shut the doors behind you. All right, so I give you 3 and 4i. Right? 4i is an imaginary number, so if I give you 4i, we automatically get negative 4i also. There's my third answer. So I'm going to write some factors. I'm going to put the opposite into my factors. Now I'm going to FOIL. I'm going to FOIL these two first, because if I do that, it's going to be a lot prettier, and I'm going to get rid of my i's. So I'm going to get x squared plus 4xi minus 4xi minus a 16i squared. That's my FOIL for these two. All right, in the middle, good things happen. These cancel. Oh, I squared is a negative 1, so this is really negative 16 times negative 1, which is a positive 16. So x minus 4i times x plus 4i is x squared plus 16. Bring down this x minus 3, and I'm going to FOIL again. And to get a good looking answer, I'm going to change the order. And there it is. I's come in pairs. All right, let me see, I think this will be the last one. All right, so I give you negative 2 and 3 minus I, and I automatically get 3 plus I, because i's come in pairs, 3 minus I and 3 plus I. Every time we have a solution, we put the opposite into the parentheses. So if my solution is negative 2, I'm going to do x plus 2. If my solution is 3 minus I, the opposite of that is changing both of them. Because if I do the opposite of 3 minus I by putting a negative on the outside, it becomes a negative 3 plus I. A negative 3 plus I, which is my opposite, there's going to be x minus 3 minus I. When you have a binomial, two terms, and the opposite is you have to change everything. All right, now I'm still going to FOIL. And I'm going to do the back two first. I'm going to take x times everything in the back. I'm going to take a negative 3 times everything in the back. I'm going to take an I, multiply it times everything in the back. And if I do this correctly, all of my i's are going to disappear. I squared minus 3x minus 3i minus 3x plus 9 plus 3i, then plus ix minus 3i minus I squared. X times the back, negative 3 times the back, and I times the back. Good things better happen. All right, I have a 3i and a negative 3i are gone. xi, I messed up something real quick. Let me back up. Let me double check these. x squared minus 3x minus 3i, negative 3x plus 9 plus 3i, xi minus 3i minus I squared. That's not the 3. I found my mistake. That's where they weren't all canceling, so I know I did something wrong. There should be an xi or minus xi. When they don't cancel, something's wrong. Because this times this is my negative xi. All right, now I'm going to try it again. My 3i's cancel, my xi's cancel. A negative I squared is a negative negative 1, which is a plus 1. So I have x squared minus 6x plus 10 times x plus 2. FOIL again. X times the back and 2 times the back. Like terms. X to the third minus 4x squared minus 2x plus 20. When we have a solution, remember if I have an I answer, I have a negative I answer. 3 minus I gives me 3 plus I. Given a solution, we put the opposite into the factor, which means we change the sign. So 3 becomes x minus 3, 4i becomes x minus 4i, and negative 4i becomes x plus 4i. Even as a binomial, 3 minus I, the opposite of that is negative 3 plus I. The opposite of everything positive is everything negative. When we do these, all of the ugliness, all the i's will disappear. If they don't, go back and figure out where you made your mistake, because that's what I did when I wasn't having my xi's cancel. So there's an assignment in the classroom. Let's get this done before next week.